Okay, for the third practicum, I asked you to come into the lab and actually measure liquid volume. And as I indicated, we were going to go from the largest down to the smallest container for questions 1, 2, 3, and 4. Each question divided into 2 parts. I wanted to know, could you identify what size of container this was, and could you tell me how much liquid was in it? I also told you on the instructions not to touch any of the containers. And so I'm going to actually touch some of the containers so that I can get them close enough to the camera so that you can actually see what I'm looking at. All right, so number 1, we want to know what size of a container is this? Well, the largest number is 250 milliliters. So this is obviously a 250 milliliter container. 250 milliliters. And please make sure you're using the right units. For our second one, the number at the top is 100. It's a 100 milliliter container. Pesky bells. The third one, this is a conical flask, and it is filled to the 75 milliliter level, but this is a 125 milliliter container. And this final one, the largest number on the plastic, and this one's very hard to see, it's 100. This is a 100 milliliter container. I then asked you to please tell me how much was in each container. And to do that, we had to get down and pardon my bald head, but you have to actually get down and get even with it so that you can see across as to how much is in it. But I'll bring this one up here so we can take a look. And so I'm going to put my hand back here, and you can see that the water comes to the 150 milliliter line. And because the camera's at an angle down, you're actually looking down, it's very difficult to see that. But that's all right. It's 150 milliliters are in this container. And I asked you to use the whole numbers on this because, as you can see, some of these don't stand quite straight up and down. This one's at the 60 milliliter mark. I indicated that this was at the 75, which you can see. One of the students the other day asked what was in these. Was it something dangerous? I wanted to make up something and say, yes, this is the mandrulipus acid. Very dangerous. But it's just colored water. So please don't get worried. It's just colored water so you can see it better in the container. And this one comes up to the 40 milliliter mark. I then asked you to do some specific measurements where you actually poured liquid into a container. In this case, into the plastic graduated container. The first one I asked you to do was to measure 5 milliliters. Well, to do that, we have to find 5 milliliters. And in the plastic is right there above my thumb. It says 5. So, being very gentle, we're going to see if we can't measure. I've got some red liquid made up here. And let's see, and if you get this right. And then I was supposed to come around, and sure enough, right here, I've got 5 milliliters of liquid in that container. And so I would come by, and I would sign off that you did 5 milliliters of liquid. Into this graduated cylinder, I also wanted you to put 20 milliliters. That meant that we had to find 20 milliliters. Well, this is in 5s, 5, 10, 15. 20 is this line right above my thumb. So we're going to come in here. We're going to pour. Bring up, 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 up. And one of the things in science that hopefully everybody's getting used to is that nothing happens in a hurry in science. I think I can get one more drop in there. Let's see. And do it. Does he do it? Does he go over? Oh, 2 drops, and sure enough, I'm right there at 20 milliliters of liquid in my graduated cylinder. So I'm going to get rid of that. Okay, then the next thing I asked you to do was to put 50 milliliters into the beaker. Now, Some of our beakers, though, don't have a 50 on them. They're done in 20s, 20, 40, 60, 80, 100. Well, in this particular one, the middle mark would be the 10, so it'd be 20, 30, 40, 50. 50 is going to be right there above my thumb. So let's see if I can get 50 milliliters into this container. And so we're going to run it up. There it goes past 40. And we're watching the line. And sure enough, I want it just to the top of the white line because then that takes up for the concave shape of the liquid. And sure enough, I'm right there at 50 milliliters. So I have done that correctly. And then finally, I asked you to put in 110 milliliters. That'll come to this line right here between 100 and 120. So here I go. I'm filling very gently, very nice and slow. I'm at 100. I come up and I come right to the 110 milliliter mark. So 110 milliliters of liquid. And then finally, I asked you to do the following operation. If you'll recall, one of the first videos that was posted at our Dexter Middle School channel was where I proved 1 milliliter of water weighed exactly 1 gram. Well, we're going to do it again, but we're going to do it a different way. We're going to take our triple beam balance. We're going to take our triple beam balance that we just used in a previous video. I'm going to make sure that this one zeroes out. Okay, we're going to make sure it zeroes out first so we can get started. And I'm waiting. It's just a little heavy, or a little light, sorry. So I'm going to run that in about a quarter turn on the adjustment. And I'm going to stand here behind you while we look, and sure enough, it's weighed in right there at 0, matching up. So, I want you to take our plastic graduated cylinder, and I want you to weigh it empty. Now, we've already done this several times. Oh, let me make sure and get all the water out. Okay, so gently we're going to set that down. We've done this before. We know that this graduated cylinder comes in at approximately 16.8 grams. 16.8, and that is lining up just beautifully. 16.8. 16.8. Next, I ask you to measure precisely 10 milliliters of water. Now, I'm not going to use the colored water because it's got food coloring in it. I'm sure it wouldn't throw it off that much, but I am going to use, I have a container of water here, and we're going to measure out 10 milliliters. There we go, past 5. Oops, just over 10. Let me put some of this back. This is what happens when you get in a hurry. And I think I need to put in 1 milliliter. That's about 3 drops. Here we go. And, still just, maybe 1. Oh, there we go. Got it. 10 milliliters. Okay, I'm going to set this back down. Yes, it's too heavy. It's made that end go up. If 1 milliliter weighs 1 gram, and we've already accounted for the weight of the cylinder, I should be able to move this 10 grams, and it should theoretically balance if 1 milliliter of water weighs 1 gram. Let's see. Pardon my sniffles too. It's been allergy season, and here in Dexter, America, it's now silage season where we're cutting corn. All right, so I'm going to run the 10s over. 1. There's 20. I've let go. And. Ooh, in this case, it's still just a little heavy. So somewhere, either I don't have quite enough water in there, even though it looks like it's 10 grams, or something else went wrong. But let's move this back 1 gram, 0.1 gram. There we go. And not quite there. Come back with 16.8. And I've got it to balance at 26.5. 26.5. So the difference between the two is 9.7 grams. What can we conclude? We can conclude that 1 milliliter of water does weigh 1 gram. What happened in our experiment? We don't know. Probably what happened was, when I put the water in this graduated cylinder, I still need about 3 drops of water to get the bottom of that concave at the line. But we are close enough. We are 0.3 grams from proving our point. So for me, we can conclude that 1 milliliter of H2O equals 1 gram of mass. And that's what we're going to conclude down here, is that 1 milliliter of H2O equals 1 gram of mass. Ladies and gentlemen, science is not always exact. Science doesn't always come out exactly the way you want it to the first time. If I were to run this experiment 5 times and then average it out, I could probably get much closer to my desired goal. But for this simple video right here, we have once again proven that 1 milliliter of water equals 1 gram.